Hey, this is going to be one of the very important video of my generic series because we are approaching one of the most confusing topic ever, what we call the producer extends consumer super rule that we have in generics or the put get methods that we have in generics. So you mostly encounter while learning generics or collection or reading Java APIs or maybe reading Hibernate or Spring APIs that you have. You might have encountered different methods where the extends or super keyword being used heavily. And we mostly ignore those keywords and we really don't understand what that method says if we are not good at generics. And we prefer to skip those things where a lot of misunderstanding basically happens in our day-to-day project. So if you are a Java beginner, then I will definitely encourage you to learn this topic because I've given you so much of examples in this particular video. Or if you are an experienced Java developer, then I'll tell you to take a break. And if you are not comfortable with this topic, learn it first. Because in an interview, obviously you're going to be getting questions about the producer extend super consume rule. You're going to be asked different questions like, in what type of collection only reading is allowed, in what type of collection you will be only be able to write, in what type of collection the read and write both are possible. What do you mean by covariant? What do you mean by contravariant? What do you mean by invariant in Java generic? So many types of puzzling questions can come in interview, but forget about interviews. I feel learning and understanding all this topic can help you to become a good developer and also help you to understand how you'll be reading the different API methods that we have in our API specs, like whether it is Spring or Hibernate or the Java itself, or whenever you are creating methods or creating APIs for your client, you will be obviously have the quality to develop a better API if you understand how you can properly use the extends and the super keyword that we have in Java generics. Well, this topic could be wrapped up easily within 20 to 30 minutes. But I prefer to make long videos because I basically give you a lot of examples. In some cases, they might not be needed if you understand them in one shot. So what I'll tell you that a lot of examples has been given in this particular video. So what you can do, you can just start learning with me and start practicing along with the video. Just take 1 day break, just save 1 day for yourself and start learning and practicing along with me. And if you are understanding in one shot, then skip the other examples given in the video and proceed to the next topic. I'll give you the complete the chapters of this particular video in the description, so you can see the topic where you are exactly interested and can skip the topic if you understand the examples in one shot, and you can skip the other examples and can directly proceed to the next topic and can easily wrap up this video within 1.5 hours. So this video can be referred by the beginners who are just learning generics for the first time. To those people, I'll tell you watch the entire video, save 1 day for yourself and just learn and practice and you will be all good. But if you are an experienced developer, just use this video the way you want. Just understand what is contravariant, covariant, extend, super, the read-write collections, the read collection, the write collection, the wildcards, what is upper bound wildcard, what is lower bound wildcard, and all that. And all this fancy looking API methods that you see all over will be super simple. And after watching this video, I'll have one last video on generics where you will be diving through different methods that we have in Java APIs where this syntaxes has been heavily used. We'll be exploring them, understanding them, and implementing them in our project. So hopefully you'll be finding it helpful. So I'll see you in the video. And if you are here for the first time, make sure to do the subscribe. If you find this video useful, then do consider liking this video because it takes a lot of time and effort making this type of video, which is really, really long. And yeah, so let's just get into the video and I'll see you there. All right, so right now, let's just try to understand about a keyword called extends. Well, when you hear out this word extends, is basically somewhat it can remind you about the inheritance concept, right? Is something related to the inheritance also we're going to be discussing right now, but with respect to generics. We're going to be saying how this keyword extends can be used in context of generics, okay? And why exactly we did that. And trust me, understanding all this simple thing can help you to understand the further things that we'll be discussing in this course. And that is going to be about the, let's say, put get method or producer extends super consumes, the terminology that we have. All this fancy looking thing will be very much easy for you once you understand this extends keyword and the way it works. Okay, we'll go into this, but step by step. So to save some time, I have created a hierarchy for you that I'll be using throughout this video. Look at this hierarchy that we have. We have a super type. Let's say object is a super type of all the classes that we have in Java. And let's say then we have a class called creature that extends, like this by default extends from object. And then we have animal that extends creature. And then we have two types of animal. One is cat, one is dog. Okay. And both the cat and dogs extends from animal. And then we have a breed of cat here, and that Indian cat. And that's a breed of, there's a specific breed that we have, which extends from cat. And we also have a dog breed here called husky, right? So this is the kind of hierarchy that we have. And I have replicated the same into my IDE that we have over here. You can see we have a class called creature, and the animal basically extends a creature that we have over here. And then we have a class called cat that extends animal. We have a class called dog that extends animal. Exactly something like this. Cat and dog extends animal. And then we have husky, which is a dog. And we have an Indian cat, which is a cat, and this extends cat. So I have replicated this whole hierarchy into this. Okay, if you want to pause it, you can pause this video and can familiarize the structure that we have, because I'm going to be using pretty much in order to make you understand all the concepts that we're going to be discussing today. But before that, one thing I'm going to be doing over here, I'm going to be creating another class. And the class name is, let's say, home. Let's say in my home, I want to have some animal, right? Some pet animals. So I'm going to say animal 1 and animal 2. Okay. And both these animals could be anything. I'm going to be making it a type T over here. So whenever I'll be initializing home, I'll be passing in this T. This T could be any animal like dog, cat, husky, Indian cat, or anything specific I can mention over here. So the type of animal 1 is T, and the type of animal 2 is T as well. Okay. So both of the animals that I'll be keeping in my home is going to be of same type. Let's say I'm going to initialize this with cat. This T will be cat. This T will be cat. So it's just like I want to have only animals of cat in my home, or I will be only be having pets of dog in my home. Okay, something like that. So this is my home class, and let me create a constructor, something like this. And I'm going to be moving out this super over here. Okay, so using this home, I'll be initializing both of this animal, and let me make it private, and let me give some accessors like some getter method in order to access the value of animal 1 and animal 2. Something like this. Okay, so once I put value inside this animal 1 and animal 2 using this constructor, then I can fetch value from animal 1 and animal 2 by using this getter method that I have provided over here. Very simple stuff. Now let's just go to our sample method, and let's just do some experiment over here. First of all, let me initialize my home that I have over here. And I'm going to be have some pets in my home. Let's say this is going to be the pet called dog. So I can just write dog type, let's say dog home. And here I'm going to be specifying the generic type. And if I don't specify anything, anyhow, it will be inferred as dog, as I've said you earlier. Or you can specify dog over here if you want. But here I'll be able to put some dog objects over here. Okay, simple generic concept. And I think you understand that. Now, same way, if I want to have some cat, I can do that as well over here. Home of cat, and I'm putting in a couple of cat object over here. Okay, so I'm maintaining the type empty. I cannot put dog over here if my generic type has been declared as cat. So this T and this T, which will be a couple of my animals, should be cat only as mentioned in the generic type declaration. So I have to revert back to cat over here. Okay. So one thing I'm going to be showing you right now. So here I have a class called home, and here I said like I'll be able to keep some animals over here. And this T is basically the type of animal that I want to put. But if you're going to see the class that I have designed over here, it has a design smell. If I'm going to come to this sample one, and what if I'm going to be declaring something like this? Let's say I'm going to say home of, instead of putting in an animal over here like dog or cat or husky or Indian cat, which are different types of animal, I will be doing this, home of integer. Okay, and let's say I'm going to say new integer and new integer over here, and I'm going to be passing in some value over here. Will it work? And ignore this. This is because this method is deprecated. But the thing that I want to show you over here, I'm able to stuff in some integer value over here as well, where this home is meant for the pet, which is animal. Okay, I can put any types of animal over here like dog or cat, or the animal object itself. I want to put it over here. But if I'm going to put animal over here, this T will be animal, this T will be animal. If I want to put dog over here, this T will be dog, this T will be dog. But what about while initializing, if I'm putting in integer over here, then this T will be integer and the animal one will be integer and animal one is integer, animal two will be integer. I don't want that. Okay, I want this T should be the type of animal. Okay, but as you can see, I can able to put an integer, or even I'll be able to put a string over here, which is a wrong thing. You can see there is no compilation error. I'll be able to define a couple of string over here, and I can put this in my home over here, and this T becomes string. This couple of T will be also be string. Now I want some kind of restriction so that this T will be only be accepting the animal. Okay, so how can I do that? So if you can see this T, I haven't specified any restriction over here. I can say this T is unbound. This parameter that we have, the class level type parameter, is a unbounded parameter that I have over here. There is no bound defined to this. Now I can set a bound to this. I can set a restriction to this. And to set this, that means I want to say this T can be only be animal or any type of animal, like dog is an animal, or let's say cat is an animal, or Indian cat is an animal, or husky is an animal, right? So this extends to cat, and cat extends to animal, means Indian cat is an animal, husky is an animal, cat is an animal, dog is an animal, or animal is an animal. Okay, simple inheritance. So I want to specify only animal over here. I want to have that bound. I want to have that restriction. And in order to do that, I can do this T extends animal. And what I mean by this? I mean by this that this T, my T parameter, which is my generic type parameter, I can only pass those type over here which extends animal. Okay, so I'll only be able to pass in type over here inside this parameter, which is animal, or which are the subtypes of animal. For an example, I'll be able to pass animal to this home. I'll be able to pass cat to this home. I'll be able to pass dog to this home. I'll be able to pass Indian cat as it extends animal. I'll be able to pass husky as this extends animal over here. So this T could be only be animal or any subtype of it. That's the bound that I set over here. But I won't be able to initialize home with the supertype of animal like creature or object. I cannot put creature over here during the initialization of home. I'm going to be telling you how and exactly what I mean by that. So let's say T extends animal over here. So if I'm going to go down, you're going to be straight away going to see some errors over here. So if I'm going to come over here, see the first couple of lines compiles over here, but this line number 65 does not compile. Why? Because I'm going to initialize home over here using string. So if I'm going to pass in T as string, you can see there is a bound mismatch. The type string is not a valid substitute for the bounded parameter T extends animal of the type home of T. So the home of T, the T can only be animal or any subtype of animal. But do we have string as a subtype of animal? If I'm going to go to the string class, does it extend or implement, animal? No, animal is a customized class. String is a Java class that we have, and the string does not extend or implement animal. So we cannot pass string over here. Okay, this is a invalid line. Okay, this will not compile. But look at that. Home of dog, I'm going to pass in the dog over here, and I'm passing in a couple of dog objects over here, and this line works fine because the dog that I'm passing over here to this home, dog is a subclass of animal. You can see the dog is a subclass of animal. I said I can pass animal directly to this home or anything that extends animal, and the dog, as you can see, that extends animal over here. Okay, so I can happily initialize home with dog. Just like cat, I can put over here because the cat, if you're going to see, the cat is also extends animal. So over here, I can put cat as T because I have specified the bound over here that anything that extends animal. So I can also pass the cat object over here and can stuff cat into my T values that I have defined in my home over here as T and T. It can happily be cat. It can consist cat object. I can pass in cat object over here, and I can assign some cat object to this T because the cat is extending animal. I think that makes sense. Or if you want, I can have another, line over here. Let's say I can directly pass in animal over here like this, animal, okay? And I can create animal object directly over here. That's also fine. I can directly pass animal or dog or cat or any other subtype of animal. I can even pass the Indian cat, okay? And just like that, I can also pass husky over here. But here is a problematic line. Can I do this? Control C, paste it over here. Can I do creature? Okay. You remember I have a class called creature as well, but the creature is the super type of animal. And this is my hierarchy. Animal extends creature. Look at my T that I have defined over here. T extends animal. So the highest I can go is animal. T extends animal. I can put anything that will be animal or the subtype of animal. So the highest type that I can put is animal. So the highest value. So the upper bound I have set over here. Here I have set the bound. And this is the highest. This is the upper bound that I have set. And I can only put animal or below that, not above that. Okay. So the highest I can go as animal, but animal super type is creature. So I cannot initialize this home as creature. I cannot say creature and creature over here. Okay. This won't work. So let's say creature home, and this won't work fine. If I'm going to hover on this, cannot infer arguments for home. And if I can put in over here, you can see that is a bound mismatch and the exact same error that we have seen earlier. Okay. So I cannot put creature over here or object over here because object is also the super type of animal. Okay, the object is over here, the highest I can go is over here. So this is also what we call upper bound. Okay, I have set the upper bound. This is an unbounded parameter. The type T previously used to be unbounded. Right now I have specified a bound over here. The bound is animal. So the highest I can go over here, highest type that I can put over here is animal. I cannot go above that. So this is also what we call a upper bound parameter that I have specified over here. This extends is used to specify the upper bound. Okay. So here, as you understand right now, what do we mean by this extend stuff over here? I'm going to be showing you a little bit of interesting things so that you can solve the assignment that I'll be giving you in the next 5 minutes. So, well, over here, this thing doesn't compile, and that makes sense. The object I cannot put over here as home, only accepts T over here. Okay, I'm going to be showing you one thing. Okay, if I want to make this code compile, I'll go to home, I'll remove this extends animal, then I can pass anything over here in this T, because the T is unbound. It's an unbounded parameter. I haven't defined any upper bound over here, and that makes sense. And now I can put any type over here. Even I can pass in string. That will also work. I've already told you, you understand that. But the problem with this approach is, let's say I'll go to my home. Okay, let's say I haven't defined any bound over here. Let's say in my getter method, I will do something. The getter method here, I'm simply fetching the animal one and returning that. But imagine I want to do something over here. Okay, let's say I want to call a method of animal. Okay, something like this. Let's say if I'll go to animal, and imagine I have a method called public void make sound. Animal is making sound. Let's say some general method that I have over here in my animal class. And let's say over here, let's say in my home, I've defined my T, but this T can be anything right now. But what I'm assuming right now over here, that the T can be an animal. If that's the case, if I assume this T will be animal, can I call animal1 dot the method of animal1? Can I do that? Can I call make sound? Well, you can see I'm not getting that in the suggestion, because the T here is an unbounded parameter. As I said, right over here, the T can be cat, Indian cat, dog, animal, but apart from that, it can be object, integer, string. I can initialize this home with any type. That bound is not defined over there. And if that bound is not defined over here, this T can be anything, then I will not be able to call the make sound method over here, which is an animal specific method. I cannot make any method call over here. So the only methods you can see over here, these are object class methods that I have over here, the equal, notify, notify all, toString and all that. So if I will not define a bound, then I'll only be able to call the object class method. But let's say I want to treat this animal1 as an animal. I want to treat this variable as an animal only. Then I have to define the bound. I have to tell the T extends animal. Okay, so if I'm going to do this, then I'll be able to call, let's say animal1 dot make sound. I'll be able to call this method. As you can see, this works fine. Okay, because I have defined the bound over here. Okay, now if I'm gonna come to this, let's say Indian cat home, let me consider this statement over here, and if I'm gonna do Indian cat home dot get animal, like get animal one, and remember in the animal one, I'm making a call to the method of animal over here, then you'll be able to see run as Java application, the animal is making sound. And obviously, if you want to get the value out of it, you can just do control 1, assigns to a local variable, and also I can print the animal that you want to fetch out of it. And I'm going to say animal1. Okay. Now, if I'm going to run this, this should work fine. You can see I'm going to extract the Indian cat, which is there as animal1. Okay. This value I'm able to extract over here. Okay. So this is a very important thing to understand before we proceed further. And this is all about the extend thing that we have over here. Okay. So as we have animal over here, I know this T will be at least an animal. It will be Indian cat. It will be husky. It will be cat or dog, or it will be an animal. It will be at least an animal. I know this T type will be an animal. So I'm able to call the method of animal because you know the way inheritance work. If this will be any any subtype, just like Indian cat also, but Indian cat is extends cat, and the cat extends animal, and the animal has this method. So the Indian cat automatically inherit this method and able to make a call to this. So to make that happen, you need to have this bound over here. Okay, I think this is understood. Well, I just want to see if you understand this extend thing a little bit. Okay, just one last question before we move further. Let's say, okay, one tricky question here. Not tricky, but I think this will be simple. Let's say if I'm gonna make this T, instead of saying extends animal, I'm gonna say the T extends dog. If I'm gonna write dog over here, do you think this make sound will work over here? If I'm gonna say, sorry, if I'm gonna say T extends dog, see what's gonna happen right now. See, I know the T that I'll be passing is going to be a dog or the subtype of dog. But the dog extends animal, and the animal has this method. Okay, so I'll be happily able to call this method over here as well. Okay, because I'm defining the type over here called dog. Okay, but yeah, let's just remove this. And I think you understand this method call thing. Well, let's just forget about that. I want to check your understanding a little bit over here as well. Let's just come out of it. Let's say I have a home class. The T will be anything that extends dog or the dog itself. Now tell me, if I'm going to uncomment this line, will it compile or it will not compile? Home of animal, just check this line out. Home of animal, and I'm stuffing in a couple of animal object over here. But what is the bound for home? It is dog. So anything which is a subtype of dog should work, or the dog itself should work. But dog is the upper bound. I cannot go above that. So animal is something I will not be able to pass over here as T. So if I'm going to uncomment this line, this will not work. Okay, I think you understand that. Okay, now another question. If I will come to this line, if I'll uncomment this, will it work? And the answer is yes, because the dog or the subtype of dog I'll be able to pass. So this will work. So if I'll uncomment this, will it work? No, because I'm passing in the cat type, and in the inheritance hierarchy, the dog is not extending to cat. Okay, so the dog thing I have to pass over here. So this cat will not work over here. Okay, similarly, this line will also not compile if I will uncomment this. I think you understand that. I have one last question. Well, if I'm gonna copy this line, and if I'm gonna make it a husky, so this thing also worked because the husky is the subtype of dog, so that works. Now, can you tell me if this works? Okay, I'll comment this line. I'm gonna say dog And I'm going to say new dog. And I'm going to say husky here. I'm going to mix the type over here. I'm going to pass one dog over here and one husky over here. Will it work? And obviously, this is going to work. And why it is working? Don't you think I'm taking the dog type over here, but while I'm going to put couple of animal over here, so what is going to be the animal type? That is going to be dog. So I'm going to put the dog type over here, and I'm going to put the husky type over here. These are two different class. So do you think it is possible? And yes, of course, this is possible. So I can put heterogeneous elements over here as well, as long as the husky super type is dog. Okay, so I can do this, right? So I can define an array list of number, and I'm going to say number list dot add. I can pass in 1, which is an integer. I can pass in let's say 10.0, which is a double. Okay, because the double, the integer that I'm passing in, all are the subtype of number. So if I'm going to go to the number, and if I'm going to put control T over here, you can say double, float, integer, long, short, big integer, everything are the subtype of number. So I'll be happily able to stuff those things in, even the type is defined here is number. The same as this, okay? So I'm going to define the type here is dog. So as long as it is a dog, husky is a dog, husky is a dog because that extends dog. So I'll be able to put the things put the thing in over here. This will not break the type safety. And while retrieving, the type safety is not only putting stuff in over here, the compiler is going to check the type safety that we are not inserting anything wrong type over here. I cannot insert a cat over here because the cat is not a dog, but the husky is a dog. So that is the inheritance relationship. So I'm able to stuff that thing in where the home is basically taking T, that will be dog, and this T will be the dog type. So if it will be dog, it can absolutely feed in the husky object because the husky is a dog. Now I will say, I will ask you this thing only for understanding. If I'm going to say dog home dot get animal 2, if I'm going to do this, then if I'm going to handle the return type, what value I'll be getting out of this, okay? Whenever I'm going to handle the return type, am I going to get a husky or am I going to get a dog? Simple. The type that I have defined over here is a dog. So the compiler will be fine as long as we are putting a dog inside it, okay? Dog or any subtype of it. But whenever you're going to be, fetching the value, it will always going to be a dog because you have specified the type. Okay, the compiler will be fine whatever you're going to be putting inside it. But while fetching it in, you will be getting that in form of dog only. It will not be husky because the compiler doesn't know if you're going to put a husky or something else, which is a subtype of dog, right? But as long as you are putting dog in, the compiler is fine. And whenever you are fetching the value, it is going to give you back as in form of dog to maintain the type safety. So the type safety is not only putting stuff inside the home, which is a generic type, which is having the generic type of dog. It is also going to maintain the type safety whenever you are going to be retrieving the element over here so that there will not be any typecasting needed. So by default over here, the typecasting is done by the compiler. It is injecting an implicit typecast of dog. So this is going to get me a husky, convert it to dog, and I'm going to be assigning that over here. Okay, hope that makes sense. And this is simple, right? So you understand this. Now, time to go for the assignment. So let's just go for it. All right, so right now let's just go to our next example. So I'm gonna comment out all this code. I don't need this anymore. I think I told you everything that I'll be needing right now to explain you the other stuff. So I will give some line breaks and I'll come out of this. I'll start fresh. So right now, I want you to write a method for me which basically sum a list of number. Okay. So first of all, you imagine I have a list of number. I say 1, 2, 3, 4, 5 in a list. So I want you to write a method for me, which will basically sum of all the numbers that I have in the list. Very simple, right? Let's try to design that first. So I'll go to this sample one class a little bit. Okay. And I'll have a method over here. So first of all, let me just clean my screen a little bit. Okay, let's just write a method. Let's say public. Let's say I'm gonna give integer over here as a return type. That's going to be my summation result. I'm gonna say sum int value. Let's say int values. And what I'm expecting, a list of integer. So I'm gonna expect a list which basically consists a bunch of integers. And I'm gonna say list of integers, and there you go. And obviously it's gonna return me something. Let's say I'm gonna say int, let's say int sum is equal to 0. And let's say I'm gonna return this sum right now in order to make my compiler happy. And I'll write my logic over here. So I'm gonna iterate over this list of integers that I have over here. So I'm gonna iterate over this. I'm gonna use a simple enhanced for loop, and I'm gonna say I'm gonna get a bunch of integer values, or I'm gonna say integer values. And basically I'm gonna do what? I'm gonna say every time I'm gonna get a value, I'm gonna assign sum plus value, and there you go. Okay. And I think it's gonna work fine. So let's just test this out. If the integer values are working fine, let's just test this out if this method is working fine. Sum int value. Let's just create a integer list and let's just pass that into this method. Okay. So right over here, let's just make that method static because I don't want to create an object of the sample one in order to call this method. So let's just go down and let's just write a array list over here which has a bunch of number. Okay, so here I have declared the array list of integer. I'm gonna add some objects inside this. Let's say I have a couple of values that I have over here, and now I'm gonna call the method over here called sum int values, and I'm gonna pass the list of integers, and I am going to handle the return type, and I'm gonna print this in over here. Okay, all good. Let's just try to run this. Okay, I'm gonna get 3 over here. So I think my method is working well. So let me just have one more values over here. Let's say 3, and let's just run this. And I'm gonna get 6 over here. So my method is working fine over here. So the list of integer thing is working good. So, but right now, what I want to have another list over here which consists of a list of double, something like this. So all good. Now what I want to do, I want to call the same method sum int value. Okay. And I'm going to pass in the list of doubles over here. Okay. Let's just see whether that works. Now it doesn't work. The list of doubles I'm not able to pass inside this sum int values method. And why is that? So the reason is simple. Because it accepts a list of integer. So I won't be able to, pass a list of double over here because it only accepts a list of integer. Okay. So what I can do, I want to utilize this method sum int values over here or over here. I want to utilize this method for, for all type of my list. I want to pass a list of array list of integer or array list of double or array list of float. I want this method to accept any type of list. So what I can do? So you might say that, okay, just change this to array list of number. Okay. So if I'm going to do this, this will also not work. Let me tell you why. First of all, let me first fix this. If this is number, then I will be changing this to number. And right now, if I'm going to change this to number, and this values that I'll be getting, this is my number. And to get the exact value, this values has different types of variables over here. Okay. So like I can get the double value, the float value, the long value, the int value. So as the list of number can be anything. So I might get a list of double, I might get a list of integer or whatever. So I'm going to say double value in order to extract the double values over here. And I'm going to change this sum to double. And I will do one thing. I will return double over here instead of integer. I'm going to return double. Okay. So just fixing this method a little bit. Okay. So right now I'm able to accept a list of number. Okay. So whatever number I'll be accepting. So I'm going to be iterating. I'm going to find the double value. Okay. So double value is a method of values. The value is basically number. So let's say I'm going to get some, let's say list of number here. Let's say numbers may be double or numbers may be float, because number is basically extended by float, double, integer, and all the subclasses. So I will be extracting the value and summing this off and returning it over here. Okay. So I somehow fix this method. Now let's just go to our code and see. Still, I can see I'm having some issues because here to the sum int values, I'm passing a list of integer to where it accepts a list of number. That's why this line doesn't work, because I'm passing a list of integer. And right over here, I have a list of doubles and I'm passing it to this method which accepts a list of number where I'm passing a list of double, and this is also not working. I've told you the reason in the last session that whenever I have list of number, if this is the thing my method accepts, that means I only need to send the list of number only, the exact type I need to send. Even though the integer is a subtype of number, I won't be able to pass the array list of integer, because in Java generics, the array list of integer is not the superclass of array list of number. Okay, I told you that, but hold on to that. So what I can do, I can comment out all these things for now, and I can take something from here and I can put this over here. I can uncomment the code and I'm going to say array list of number. Okay, and let's say right now I'm passing in this, and then I can say sysout, and I can call the method sum int values, and I can pass the list of integers that I have over here, or I can say a list of numbers to be more specific, and I can pass in this to here, and this should work fine. If I'm going to run this, I'm going to be getting my value as 6.0. By the way, the values that I'm passing here are integer, but if you remember, if I'm going to go to this method, I'm accepting a list of number and I'm getting values as double values, right? So, and I'm returning a double. That's why, the output here is 6.0 instead of 6. If you want to return an integer, you can just do value dot integer value. Okay, you can just do value dot int value rather, but I'm writing double value here because right now if somebody will pass the double thing, let's say 1.0, 2.2, 3.2, the method will also support that, and my double thing will not be stripped out from the final result. So here I'm going to get 6.4. If you're going to return an integer instead of a double, then this 4 thing will be stripped out. Okay, so anyhow, this thing works. But the thing that I want to tell you over here, I need to exactly pass the array list of number over here. I'm passing the list of number over here inside my sum values method in order to make this method work. Okay, but if I want to pass a list of integer over here right now, let's say I want to make this thing work. Okay, what I want to do here is I want to define a list of integer, and then I want to pass that list of integer over here to this particular method. Then this will not work. Okay, and the same as the list of double. I cannot pass a list of double to this method because it accepts a list of number. So even though this list of number, the type here is number, the generic type, I'll go over here, even though the integer or double are the subtype of number, then also I won't be able to pass it in over here in the method parameter. The list that I'll be passing over here will be exactly the list of number. I've told you about this in the last session, but here is a little bit of refresher that I want to give you. I told you this in the last session, but just a quick refresh. So imagine you have number, and in Java, integer is a subclass of number. So I can directly say number n is equal to new integer. So it's kind of covariance thing going on over here. So in the left-hand side, the declaration is number, but I'm assigning an integer value because the integer is a subtype of number. So whenever I need a number, I can define a more specific type over here. Instead of number, I can define new integer. Okay, that's fine. Okay, so this is somewhat we can call a covariance thing. So when I need fruit, you can give me an apple. I said, hey, I need a fruit. You said, okay, you take apple because apple is a fruit. Something like this, which is happening over here. I need a number, but you are giving me an integer because integer is a number. That's fine. This basically compiles fine in Java. So this is what we can kind of say covariance. Okay, but the same thing is not possible in generics. If list of number is there, I cannot say a list of integer is the subtype of list of number. This is wrong. Okay, so list of integer is different thing, list of number is different thing, and all these things has been maintained because we need to maintain the type safety. I have told you about this thing in the last session, but this is a quick refresher. I can say if somebody needs list of number, then I will be giving him list of number in generics. I cannot give the list of integer. So this is not possible. I cannot say array list of number is equal to new array list of integer. This is wrong in generics. And the same as list of number, let's say we have list of double. The double basically extends to number, but this is wrong. Okay, this is not possible. I cannot say array list of number n equal to new array list of double. So this is wrong. But in plain raw Java, this is possible. I can say a number having a subtype called double. So I can definitely write number n is equal to new double of 10. So this is correct, but this is wrong. So what we understand over here is that if somebody asks a list of number, we have to give him a list of number. If somebody asks a list of integer, we need to give him a list of integer. Just like our previous method that we have developed, it accepts a list of number, means we need to feed in a list of number. We cannot give a list of integer or a list of double where a list of number is accepted. So that's why we call generics in Java are invariant. This is not covariant by nature. Covariant cannot be achieved by default like this. This is what we can say, okay, this is covariant. When we need a number, somebody give us an integer. When we need a number, somebody gives us a double. That is fine. Let's say we need a fruit, somebody gives us a banana because banana is a fruit. When we need a fruit, somebody gives us an apple because apple is a fruit. That's the covariance. Okay, covariance means when some type you're accepting, some more specific type is given to you. Okay, this type here is changing. That can be given to you. But generic in Java are invariant. Understand this word, invariant. Generic in Java, this is what we call invariant. This is what we call invariant. Invariant means, look at this. Generic in Java is like this. Okay, if this side is array list of number, we must give a array list of number in the right hand side as well. Okay, whatever side has been asked, that side the same type will be given over here. It cannot be changed. Invariant means it cannot be changed. Okay, the variant means changing. Invariant, it cannot be changed. Okay, so array list of number is asked, you need to provide the array list of number. You cannot give array list of integer or array list of double because the integer or double is the subtype of number. That's not possible. So this is correct. These two things are wrong because this is some kind of covariance thing we are trying to achieve over here, which is not possible in Java generics. The Java generics are by default like this, what we, in simple word, what we call invariance. The Java generics are invariant. This right hand side cannot be substituted to a specific type. Okay, so the covariance, as I said in the last session, is not directly achievable over here in Java generics. Okay, that's the problem that we had over here, and you can see that problem that we are having currently over here, because in this method we need a list of number, but what we are passing over here a list of integers, and we cannot assign this list of integer to this list of number. I cannot say this is possible. Okay, I cannot assign this to a list of integer or this to a list of double. Okay, that's the problem that we're having over here. So the covariance is not possible directly over here with the generics type. So what is the solution? So the solution is pretty simple. Okay, so what are the different way you can solve this problem right now? So I not only want to pass in a list of number over here to this sum int values, I can also be able to pass in a list of double over here, or a list of integers that I have over here as well. Okay, so can I make this number as t so that it can be of any type? Can I put over here, I can define the t over here. Can I do that? Yes, absolutely, that's fine. And obviously the list of integers, I can make it t as well. That is going to work. But here I have a problem. So if I'm going to make it t, you can see if I'm going to do Control S, this compiles fine. Well, why this is not compiled? Because the return type is double. Okay, that's the problem, because here it is returning double, right? I've changed the double as the return type. So I can see right now the sum int values. Now I can say sum any value. Instead of saying int, I can say sum any values over here. Now if I'm going to see this method, so if I'm going to come over here, sum, I'm going to say any values, this works fine over here, and you can see sum any values, and here I'm passing in a double, that also works fine over here. And let's say here is a list of number, and let's just see sum any values, and this also works fine over here. Okay, so this compiles when I'm passing a list of integer, list of double, a list of number, all the all this code are working fine. But let's just go to this method. We have a small problem over here. Now the values that we have over here is of what type? Is of t type. And you can assume like why we're having this problem. Whenever I'm saying values dot double values, why I'm having this issue, you can imagine. I cannot directly sum this up because I do not know what this value will be. This t can be anything. Now anything can be passed to this. This t can be a string. This t can be a double. This t can be an integer. This t can be a float. The t can be an animal. The t can be anything, right? So that's why I'm not able to sum this t, this values over here with this sum that I have it over here. Okay, and I have told you the reason why this dot double value is not working over here. You can just recap your previous understanding and you can directly give me the answer why this method is not working. Because I told you this double value is a method that is available inside the number class. like in the number class, if I'm going to go to Control-Shift-T, number, I have Command O, and you can see I have a lot of method, int value, long value, float value, double value, in order to extract value from a number. But I won't be able to use that method directly over here because this T is an unbounded type over here. With the T can be anything right over here. So it can, if you're going to do values dot, you're going to be only be getting the methods which are of object type. I have told you that before. So if I want to use number type method, then I need to define this T as a number. And obviously I want to sum any values, any number type value. I want to sum this particular method can get a list of T. This T can be a list of number, a list of integer, list of double, list of float, list of big integers, or the decimal value I can get. So all this value of T that I'll be getting, that should be number, okay? And if I want to define a bound for this T, then first of all, I need to define a bound over here. I can define T extends number over here. And if I do this, then only I can be very sure this T that I'll be getting, somebody will be passing numbers only. Now somebody cannot call this method and can pass list of string to this method parameter. That is not possible because right now I've defined a bound over here. And this is my upper bound. The highest I can pass to this method parameter, this T can be number or anything that extends number. That means the list of T can be list of number, a list of integer, list of float, list of short, list of byte, or anything that extends number. As I said, Control T, all these values, big decimal, big integer, and all this thing we can pass because those are the subtype of T. Okay, and I did pass that over here. Okay, and now I can happily use the double value method over here right now. Okay, and now my method works fine. And if you're gonna see, all these methods are working fine. Now it's a list of integer. I can happily pass that to sum any values. List of double, happily I can pass that to here. List of number itself, I can happily pass this list of number through this particular method because right now it takes a list of T. I've defined the bound. The bound of T is either it will be a list of number or anything which is below the number. The upper bound is set over here, and the upper bound that I've set here is number. That's the highest I can go, and this could be number or anything below that. Okay, and you can see number works fine, or anything below number will be integer or double, that works fine. But if you're going to define a list of string and going to pass into this, let's say if you're going to define a list of object over here, and in the object I can pass in the double value because the double class basically extends object. So I can pass in double value over here inside this number list that I have defined, but I cannot pass this list over here because here I'm passing a list of object, and I cannot pass the list of object to here because it will only accept value where I have set the bound as number. Okay, but the number super type is object, but the bound, the upper bound that I have set over here is for T is number. I cannot go above the number. I cannot go above the number in the inheritance tree. I can go below that. So the object is the super type of number, so I won't be able to pass it over here, but I can happily pass the number itself over here because I've set the bound over there. Now all this method will work fine if I'm going to run this. So this works fine. So 6.0, 6.4, and what about the other one? I think 3 times I'm printing it. First time, second time, and third time. So run this. 6.0 for this. Let's say 6.4 for this. Oh, here I'm not printing this. So there you go. And run this and Java application. Now I'm able to print all my values over here. Now this happily takes any type of number related values over here. So this is one way to fix this method. Well, one more approach that you can have over here, if you do not want to have this drama of defining this T type by declaring the T type over here, here you are defining this T. As I said, this is the method signature. Here you have to define the T for this. If you don't define the T, this will not compile. So instead of doing this, you can also use a question mark over here. Okay. And here the question mark means you can able to assign any type of value to this parameter. Now list of some unknown type. You will still see all your methods are compiles. Right over here, it also compiles where you're passing in double. Here you're passing in number. This also compile. But the problem here is that you will be able to pass a list of string over here as well to this method parameter, or a list of animal over here as well to this method parameter. We don't want that. And another thing is that you can see right now here, this cannot be T anymore. So what this will be, you know that you will be only be accepting number over here. So I can say this will be number. Okay. If I'm going to say this will be number. Okay. Then also you have a problem over here, because the list of integers, you cannot say you're going to be getting, let's say I'm going to change this to list of numbers right now, list of numbers. And let's say I'm going to put it over here. Now you have a problem, because the list of numbers, you cannot say you're going to be getting list of numbers all the time. It could be list of any unknown type. It could be list of string, list of double, list of float, list of animal, list of employee, or list of anything, right? Anything it will be able to accept over here. So that's why it is saying that you change it to object. Okay, but if you're going to change it to object, now this double value will not be able to access, because the object class, we don't have this method. We have this method inside the number class. Now, the same thing we can do over here. We can define a bound. This is an unbounded wildcard. I have told you that in the last session. Now we can define a bound for this wildcard. We can do extends, and we can just say number over here as well. So if we can do that, you can see everything works fine. So in this way also we can fix this method. We don't have to define the T. And again, this is what we call a upper bounded wildcard. This is a wildcard list of any unknown type. This wildcard means now list of any unknown type that extends number. So I can pass in anything which is a number or below that. So the same concept applies to over here, and you can see all this code compiles. Right now I can run this, so you can see all my output over here. So I can pass in a list of integer, I pass in a list of double, or I can pass in a list of number, or even I can pass in a list of float to this, or I can pass in a list of big decimal to this, as long as that extends number. Okay, so I think you understand. You can replace that bounded type parameter to wildcard. So this is a bounded wildcard. We can say here we have defined the bound. So we can say this is a upper bounded wildcard. This is the upper bound that I have set. We can go highest to this. We cannot go higher than this, but we can go below than this. So this is the upper bounded wildcard. I think you understand this concept till now. And now let's just deep dive further, and let's just try to enhance our knowledge by understanding a lot about why we need this thing, and some more interesting fact about this extends keyword that we have over here. Now we are really diving deeper into generics. Let's just try to understand the rest of the things right now. Hey, before I give you the next lesson, here is a tricky question for you, because a lot of time you will face this kind of question in the interview, and some people actually try to do that thing because it is very hard for them to understand what this exactly mean. Okay, so how they try to solve this particular problem that we have solved over here. So basically here we have solved the problem that we can have a method which is more general, and our API method right now can grab any list which is a number list or anything that extends number, like list of integer, list of double, and all that. Let's say some people, if they don't understand this, so what they will do, let's say I'm gonna comment this, they'll try to create method like this. Okay, let's say I'm gonna remove all the logic for now, let's say, and let's say I'm gonna say a list of number. Okay, let's say I'll say sum any value, and this will accept the list of number. I'll overload this method like this. Okay, and I'm gonna say this one will have list of integer. Okay, and again I'm gonna overload this method, and I'm gonna say list of double, and like that I can give overloaded method, okay, the same method name with different parameters over here. So will it work? You can already see there is a error over here. So this might be an interview question, or you might ended up doing, maybe not doing, trying something like this in order to solve the problem. Let's say sum any value, and you have different overloaded method where you can accept different types of list of values over here, and you'll try to sum that up. But this thing will not work. You cannot have overloaded method with list of different parameters, because if you know the the type eraser concept in the runtime, this thing will be stripped off. The number will be stripped off. It will be only be list. The list of integer will be stripped off. The double will be stripped off in the runtime. So all these things are compile time thing to help us to protect adding or getting only specific type of elements. So generic is a completely compile time concept. I have cleared that in the lesson number 1 only. So you won't be able to pass in things like this, because end of the day, it will be only be a list. So you cannot have 3 different methods where you are accepting the same type parameter, right? That's not possible. So if you're gonna hover on this, erasure of method sum any value, list of number is the same as another method of simple one, because end of the day all these 3 methods are same, because these things will be stripped out in the runtime if you remember my type eraser concept. So if you're going to remove all this method, then all these 3 methods are same. So you cannot have all these 3 methods over here like this. So you need to understand, okay, what I have done over here before you move forward. And I think you understand them. Okay, this is very simple. We have taken our enough time to learn and understand what is this. Okay, and this is, by the way, what we call the covariance thing. Don't we? So see, I told you in the last session, generics are invariant, and I've shown you this slide. I have told you you cannot do something like this. Array list of number is equal to new array list of integer. Array list of number is equal to new array list of double. You cannot do something like this. Something like this is not possible. Let's say number n is equal to new integer of 10. Number n is equal to new integer of double. So double and integer are assigned to number. So this is not directly possible in generics. So if an array list of number is accepted, means you need to give an array list of number only. You cannot give an array list of double or array list of integer. That's why I told you generics are invariant. It cannot, the change is not expected over here, or something cannot be substituted over here in the right hand side. So it should be the exact match as the left hand side over here. But right now what we have done, we have used this extend thing, and now the list of this is accepting any type of list which extends number. Like we said, we have passed in a list of integer over here. Okay, array list of integer, or array list of double also we have passed into this. So what we exactly did here, in simple word, Control C, if I can come here to give you some demo, we did this. if we have this list of number, we can assign that to a new array list, okay, of integer, okay. That is possible. Now this is not complaining. So we kind of achieved the covariance concept over here, not directly, okay. So if you're gonna write it number, means this should be number only, okay, because the generic by default is invariant, okay. It cannot be substituted to array list of integer. That is not possible. So in order to achieve the covariance concept, what we have done, we have used the extend keyword. We just said number, but I can say anything that extends number. So by default, the covariance is not possible. But if I'm going to do this, then you can see I can define a list which is number, or I can define a list which is integer, or I can define a list which is double. We can assign a list, not define. We can assign a list of double to this, which need anything that extends number. Okay, list of any unknown type that extends number, and we can define the double type over here. So where a more general type is accepted as number, we can give some kind of substitute to this, some more specific type substitute. We are saying array list of double, because double the subtype of number. So I can pass in double. I cannot pass in string though, because string is not a subtype of number, but I can pass in double, I can pass in float, I can pass in the number itself. I can pass in the number itself. So I can kind of achieve the covariance in generics right now by using the extends keyword. Okay. So in real time, it should not be like this. It should be something like this. Let's say Control X, I'm going to put it over here, and I'm going to define this, okay, array list of, let's say array list of integer. I'm going to say array list of integer. Let's say I'm going to define an array list of integer. Let's say array list dot add, and I'm going to pass in a integer array list of add, and I'm going to pass in a integer, and I can assign this to this. Okay, so anything that extends number, I'm passing in a array list, let's say array list of integer over here, and I'm assigning to this, and this basically works fine. Have a look into this code. Okay, so this works fine. So look at the assignment. So I have achieved the covariance in generics by using the extends keyword. So to number, and I'm assigning a list of integer. I'm assigning this to this. Makes sense? Okay. So I have achieved covariance over here, but there is a price that I have to pay for this. I have achieved it. That's good. Okay. So I kind of achieved the same thing over here in generic type as well over here, but with a little bit of cost. And the cost is this. Okay. So let's say I can say list of number. Okay. This one that I have defined over here. I cannot add an element to this. I cannot say add of 4. Okay. I cannot say that. Okay, I won't be able to add anything over here if you're going to use extends keyword over here. Why is that? I'm going to be detailedly telling you about that, but a very simple scenario you can think of over here, that if in case it is allowing me to add anything to this particular list, then it could have been messed up, because as this is a list of number or anything that extends number, then the compiler will only be seeing the left-hand side. Always it is going to see the left-hand side, as I have told you. And this is my list declaration. Okay. So I'm going to happily put any value of number. Let's say I can also be able to put 4.0 or something. Okay, 4.0 is a double value. I'll be able to happily add it if my compiler will allow me to add this particular element to this particular list. Because this is number, the super type is number, I'll be able to add this, right? Isn't it? That's possible. You can see this. Let's say list of number, let's say number list. Then I can just do number list dot add. I can add 1, which is an integer. I can add 1.0. I can do 1.0f, which is a float value. I'll be able to add anything to this list. But why, if I'm going to do this, why it is not allowing me to add this? Because if you're going to, let's say, forget this part. Let's say if it is going to allow me to add this particular thing, then think there will be a problem, because the compiler will say this is number, okay, or anything below that. That's my upper bound. That is the covariance that I have achieved using the extends keyword. Then if I'm going to put in a double value, what if here I'll be assigning this array list of integer that I have defined over here to this particular list. That means if this would have been allowed, then I will be able to put a double value into this array list of integer, isn't it? So this array list of integer that I have over here, right now you can think I have declared it over here. Now this guy is having the reference or pointing to the reference of this. This is my actual list. This list, I'm assigning it to this declaration. Here, this is not the actual object. This is just the declaration. Here, I'm assigning to the object. So this is my main list object where I'm stuffing my things. Okay, 1 and 2, I've stuffed it over here. Then I'm assigning it to over here. Then if this allow me to put anything over here, then I might put a double value or a long value or a big decimal value to this particular list, which is internally pointing to this list. And in that case, this 4.0 could have been added to this particular list that I have. And the output of mine will be, if I'm going to print this, 1, 2, and 4.0. So 1 is an integer, 2 is an integer, 4.0 is a double. So I'm putting a double to this particular list, which is a very, very bad thing. And the compile type safety, we will be losing it if it will allow us to add anything to this particular list, which is internally pointing to this list. Okay, so that's why if you're using extends over here, you won't be add anything to the list. The only thing you can do is over here, you'll be able to read from the list. So that is the use of the extends. So you can do what? You can happily do for, okay? And you can just do, let's say, number is equal to number list, or let's say list of numbers, whatever this is. You can do this, and then you can read from it. Let's say sys out of number. Okay, so I know anything that I'll be getting from this list will be number. Okay, so that's why I have cast it to, I have used number over here, because this is the type, this is the bound that I've defined. I've written that bound, then I'm trying to iterate the values over here. Now I'll give a separator over here. Let's just say sys out, and I'm going to say stars here so that you'll be able to see this. Now run this Java application. You can see I'm getting 1 and 2. So this is how this extends keyword is getting used over here. Whenever you're going to see this extends keyword is getting used, mostly we'll be able to retrieve elements from that. So let's say here is the list defined. From this list, you can think this is a kind of box where we have some list of number. We don't know what kind of number it is. It can be a list of number or list of integer, list of double. It can contain anything. Here it is containing integer, but it can contain anything. You can think this is a box. This is a mystery box that we have. Inside that, whenever we're going to be fetching something, we can get number only. That is the guarantee that the compiler will give you, because the compiler will give you the typesepty over here. You can see the list of number. Whenever I'm going to fetch, I'm going to get a number. You cannot say integer though over here, because now you can see it is complaining because there is a type mismatch. This list of numbers that you have defined over here, the bound that you have defined over here is number. If you're going to hover on this, cannot convert from element number to integer because I have defined number over here. So you can stuff anything, any list to this particular list that I have declared over here. Here you are putting an integer list. You can put a double list. You can put any list which is number or subtype of number. So the compiler knows that, well, in this box, I will be able to accept number, but I don't know what kind of number. It can be integer, it can be float, it can be double or anything. Okay, so you cannot cast it to a specific type, but you can safely retrieve it as number over here because here in the declaration you are specifying number. So you can grab the element from the list and can print it or process it. You can do it safely. Okay, you can just happily get the elements as number. Let's say here you are passing a double in a list and you are doing 1.0, let's say, and 2.0, and let's say this is list of double, okay, like this and like this, and I'm going to pass in this list of double over here. Okay, so this logic remains same because the list of numbers could be anything. It is a box where we can feed in any type of numbers, right? So this time we have doubles inside this particular box. So we will be able to process them as number because that's what we have defined over here. Okay, so just one final takeaway, that whenever you see this, mostly it is going to be used as reading purpose. If a list is defined using this, that means it is used for reading purpose, or it can be used as a producer. So you can think this list of number is a producer which is going to produce some elements to you, and you will be happily iterate over the list and can grab those elements. So you can always use this list where you can grab things in, but you cannot use add method on top of it, and you cannot add element to this particular list where the extends is used. It cannot consume elements. It can only help you to produce elements so that you can grab the things in. You can read the elements from this kind of list when you see this kind of declaration. That means you will be always will be able to read things like this, but you won't be able to add things to this numbers that add. It will not let you add anything over here because we don't know the exact type of list that we'll be getting in the runtime. Will it be an array list of double or array list of integer or array list of float? We don't know that. So we won't be able to add anything over here, because if you're going to add a double, what about if you're going to get a array list of integer over here? If you're going to get array list of double, that's fine. We'll be able to add that. But what about, if I'm going to get an array list of integer, array list of float? So it will not allow you to add even a double or an integer or anything over here. Okay, so add is not possible. So that's the very important point. Remember that. But this is just for understanding, but I'm going to give you a good example right now where this kind of thing is getting used in practical. Let's just get into that. All right, so in the last session, I think we have done all this stuff that I don't want to use right now. I want to get straight to the point because I do understand that you guys right now are becoming comfortable with the things that we are discussing. So let's just get into one of the very famous rule that we have called producer extends and consumer super. By the way, I have taken a small break. I just slept overnight, and now I'm done with my office stuff. It's 11:47 a.m. and I think we can just get started and continue this particular series right now. But I'm gonna club everything as one video because I think you can give it a watch in one go and can start practicing all these things in one shot to make the most out of this video, because I know people get confused with this topic. So I'm going to be giving you a lot of examples. Doesn't matter how many people will be watching this video, but if one people or one person is watching, I just want him to make comfortable with this particular topic. That's my goal. And let's just see if we will be making these things simple. But before that, let's just do one thing. I will be getting rid of all this code that I have written. Maybe I will comment everything. What I'm going to do, first of all, I will go ahead to my sample1 class and I'll start create a method over here. And I want you to have a look into this method and tell me like the learnings that you get so far. Just apply all those learnings and just try to understand if the things that I'll be discussing will be making sense. Okay. Imagine I have a method called public void display numbers. Okay. Imagine I have a method like this called display numbers. So, you know that if I'm going to take a list of number here, then there is a problem over here. And what is the problem? The problem is I'll only be able to pass a list of number to this particular method parameter because the Java generics are invariant. Invariant means something which cannot be substituted. So I cannot pass a list of integer or a list of double or list of float to the list of number. So that cannot be passed to the parameter. We have already discussed about it. So that thing will not work. So what we can do, we can just pass in a list of question mark. That is also possible. But I told you, if we can put a list of question mark here, we can consider the list of question mark as a super type of list of number or any type that we have. Let's say list of float or list of double. They all are, maybe you can consider them as a super type of list of question mark, just to make yourself a little bit of comfortable. Maybe you can think in that way, that list of integer super type is list of question marks, so that you will be able to pass a list of integer to this method parameter, or a list of double to this method parameter, or a list of string to this method parameter, or a list of animal to this method parameter, because it can accept a list of any unknown type. So, that is one thing that you can do. But again, the question mark over here can allow any type, but I want to say display number, so I want to make it specific to the number, and that's why I'm going to be using extends number over here. Now this display number method can display me any type of number, like the number itself, the list of number, or the list of integer, the list of float, or list of decimal, big decimal, and all that, right? Whatever subtypes that we have for the number, we can pass it in over here. Now, here is a very important rules that we do have. Don't get confused about that particular rule that I have said. That is a rule basically called producer extends super consume. So I will basically tell you about this rule a little bit right now. I have already given you some hints. Let's just first understand this PE part, producer extends part. Then I haven't discussed about the super keyword. I'll be come back to this and I'll be discussing about it. But for now, let me just concentrate on this PE, producer extends. So what do we mean by that? So here, as we can see, we are using the extends keyword over here. And so as I have told you, whenever you use extends, you will only be able to read from this particular list. Well, the actual list will come in runtime. We don't have the whole to that particular list yet, but whatever list that we'll be getting over here, we will be able to consume elements from that particular list. Or what we can say, whatever list that we have over here, will be only be able to process the elements from that particular list, or will be only be able to read elements from this particular list. Okay, so whenever you see extends means will be only be able to read. Okay, so you can treat this list as a data producer, and we want to process those data that this particular number list is going to be producing. For an example, what we can do here, I will come to down and imagine I want to call that method. So is that method is static right now? Let's just make that method static so that I can directly call this method. Okay, display numbers. So I'll come inside and I'll just stretch it out a little bit, give some white spaces here. And here I'm going to be calling that method display numbers. And imagine I want to print a list of number. So I'm going to be saying a list of integer. I want to pass in inside this particular method parameter. Will I be able to do that? Absolutely, because the display number here is basically text anything which is a number or that extends number. So I can pass in a list of integer. So imagine I can just do a list of integer, list integers is equal to, and I can directly create a list of integer. I can just say a list.of and I can pass in some integer value. Now this is an integer list. Well, whenever you're going to be passing something over here, you can hover on this off method and you can see now it has been casted to the integer type. I've told you in our generic method section that here it will see the target type that I have defined here, integer. So the off method, the list of off method is returning me a list of integer over here. If you're going to change this to number, then according to the target type, now this off will give you a list of number right over here. You can see now it is returning you a list of numbers. So that's how the generic method works, but that's a different story. You can also create a new array list over here and can put some stuff in. That's also fine, but I'm going to say a list of integers over here and can pass this in over here. So it is simply taking a list of integer. Just like that, I can put some list of double over here. Okay, so here I have created a list of number and a list of doubles as well in a conventional way. If you want to take a list of example, you can also do that. But I just want to have some mixture of different formats just to make you comfortable. Okay, so now I can call the display numbers method right over here. And I can pass in the list of numbers that I have. And similarly, I will copy this method and can put it over here and can pass in a list of doubles as well. So just like that, you can also create an array list of float, and also you can pass in the float value over here in the display numbers. So let's say if you are passing a new array list of double, so let's say this is a new array list of double for an example, and if you are passing this list over here to the display numbers, then you can absolutely do that because it takes number or any subtype of number over here. So to this number list, if I can put it over here for sample, for an example, just to make you understand. Okay, to this number list, I can do new array list of double here. I can add a double list. Imagine this is your double list and you have some values inside this array list. Okay, you can safely assign this to the number list, or you can assign a list of integer. That's also fine. You can also assign the list of float. That's also fine. Okay, or you can assign the list of number itself. That's also fine because you have specified the upper bound over here. The highest you can go with this. So the compiler will say, okay, treat this number list that you have declared over here. You can treat this as a box. In that box, the compiler is going to allow any type of number, the number or any type of different type of numbers that we have, like integer, float, or whatever. But what it will allow you to do, let's say it has a box and it says that, okay, I have a box. In this box, you have a bunch of number. So I don't know what kind of number that you have. The number could be anything. As you said, right over here to this display number, I am basically passing in a list of numbers over here, a list of integers over here, a list of double that I have assigned to this particular method parameters. So this can contain any type of numbers in the runtime. Whenever somebody will call this method, they can call this method and can pass all those different types of value. So what this basically say, okay, I'm fine to accept anything, okay, which is number or any subtype of number, but you can treat me as a producer, right? So I have a box. In that box, I have a bunch of number. I don't know what kind of numbers that you have. It might be double, it might be float, it might be something else that somebody will pass in the runtime. So what you can do, you can actually fetch those numbers that you have. If you're going to do number list dot get of something, let's say get of 0, see in what format it is going to get you the data. If you want to do control1 assign statement to a new local variable, it is returning you in form of number because the bound you have specified here number. So it is saying that, okay, I have this list. Okay, this list will come in runtime. This list could be anything, but I know somebody will call this method and they will put some list of number inside this. So I have a bunch of number, but I don't know what are the numbers exactly that we have. It might be list of number, list of integer, list of double, list of float, list of decimal, whatever. So what you can do, the box that I have, it has some number. So whenever you're going to fetch this, you will be get in form of number only. You cannot say that, okay, I'm passing in a list of double here. I'm creating a list of double, passing that inside the list of like the display numbers over here. So inside the display numbers, you cannot expect if you're going to say number list or get of 0, and you cannot do like, I want to get it in form of double. And now it is going to straight away give you an error over here. It'll say type mismatch, cannot convert number to double. It cannot convert the number to double. And that makes sense because the compiler doesn't know what exactly that you have inside it, inside this particular list. Okay, it could be anything, right? So it will allow you to retrieve, but in a more generalized form. So even though you're going to put float list inside it, even though you're going to put double list or big decimal list or the number list itself, you can safely fetch it as this bound that we have, because this is the super type that we have specified over here. So it will help you to fetch the items that you have inside this number list in form of number because you have specified the type over here. Okay, so that's how you can do the reading over here. So you can do for, and you can fetch the item from the number list, or you can process the item. So number list, let's say you can just safely do number because it is the bound is written over here, and you can, let's say, item, and you can do sysout of item here. Okay, and that works. Now for every type that you are defining and passing it over here, the integers or the doubles or anything else, all these things will work fine. If I'm going to run this, see, the method works for all these different types, and we will be able to fetch the data for each of the lists that we are passing. So that's the only thing that you can do over here whenever you use extends. So whenever you see extends, treat this list as a producer of data, so you can get things out of this particular list. And whenever you are getting things out, or whenever you are reading from the list, so you will be able to read the list in form of the type that you have defined over here, the bound that you have defined over here. Okay, so for the reading, the extends is basically used. So the rule that I was saying here, PECS, producer extends, super consume, PESC. Okay, over here the producer extends means the extends is used for the producer list. So whenever you are designing any API method, if you are using extends keyword, that means you will be using it for reading purpose. Imagine, let's say you have some customer list over here. Imagine you will be reading those customers and sending the customers an email. Or you have a bunch of things that you want to read and process it. That you can safely do over here. You can see over here also what you can do whenever you are reading the item is of number type. So you can just simply do item dot double value. You can also use the method of this number class. It's not a class, it's an abstract class, I think. Yes, you can use all these methods that we have: int value, long value, float value, double value, and all that. Safely you can do that. But what you cannot do, you cannot add any items to the list, as I have said you before. You can also do this. If you want to read anything, let's say a number list dot let's say get, you can safely do. Or if you're going to do size, that's safely you can execute this line without having any problem, because this does not involve any class level parameters. So if you're going to go to the size, is part of the list class, but here we have the e parameter. So wherever you have this e as a parameter, for an example, if you're going to come to the add method, it takes a e, it takes a class level parameter as a method parameter. You cannot invoke this method. You cannot say, you cannot add anything. You cannot, modify the list over here. So you cannot do number list dot add, as I said. You cannot do this. You cannot say number list dot add. So if I'm gonna see blindly, this is a number list. So it extends number, means I should be able to put any kind of number here. I could be able to put 10 here, or 10.0 here, or 10.0f here, but I will not be able to put it. Understand why you are not able to put it? Because it's very simple. Imagine this scenario. Let's say here I'm creating a double list and calling this display number, right? So here we are only be allowed to read the list. But let's say if in case the compiler would have allowed us to add something, then inside the double list that we are getting, so we are getting this. So we are, so what we are having, and then we have passed, let's say, copy this, Control C, just for sample, don't get confused. Let's say we have this, and then we are assigning this to this. Okay, imagine this is what we are doing, right? We have a double list and we are adding some stuff to the double. Then to this, we are assigning the list of doubles over here, right? Now what we are doing inside this method, now this double list has been assigned to this, so we'll be safely able to read all these items. So that's what we are doing. But imagine if this line would have been executed, then into this list of double, so now we are doing number list dot add. So the number list is pointing to list of doubles, to this one. So this is only one object, but this reference that we have is pointing to this list. Now we would have able to add this elements. Now, if we want to do this, see, we would have able to add this float value to this double, and that would have been that would have been a problem, right? So remember that whenever you use extends, this add thing is not possible. Okay, so you won't be able to add elements over here. Okay. I will give you another example because it's confusing for people in the first shot. If you understand that, that's good. But let's say I'm going to give you another example. Let's say I will be create another method. Now let's just see our hierarchy over here. Let's say animal, cat, dog. They both extends animal, and Indian cat, husky. They are extending the respective type. And this is the complete hierarchy that we have. Object, creature, animal. And then this is the thing. Just familiarize yourself a little bit. Now let's just get into this. Now let's just go back. Imagine I have a method, public, static, void, display, animal. Okay. So think about it. I have this method and here I'm writing list of animal I will be getting. And I'm going to say list of any unknown type I'll be accepting, which extends, let's say, animal. For now, I'll be writing animal, then I'll confuse you a little bit. Okay, so I'll be writing animal list over here. And as I said, if it is extends, then I can treat this as a producer because I'll be getting animals in the runtime. This animal can be animal itself or any subtype of it. So as long as the animals that I'll be getting, whether it is a cat or a dog, because they both are animal, they have extended to the animal class. Cat is an animal, dog is an animal, right? So I can just do for, and I can safely read from this animal list. No compilation error. I'll be safely able to read the data as animal. So whenever you're going to do animal list dot get of 0 or get of 1, you will be getting an animal back. Okay, you cannot get a specific item. Like you cannot say, okay, get me a cat back, get me a dog back, because looking into this, the compiler doesn't know what kind of data this is going to be holding in the runtime, right? So you can call this method, you can pass a list of animal, list of cat, or list of dog. So what you can pass to this? You can pass a list of animal to this. Okay, you can also pass a list of cat to this, or what else you can pass? You can pass animal, a cat, or you can pass a list of dog to this because it extends the animal. You can also pass a list of Indian cat to this, or you can pass a list of what else? Husky to this. Okay, these are the lists that you can pass to this method parameter, right? So let's say somebody is passing a list of cat. Okay, so this animal list will happily allow it. Okay, so if you are like while fetching the elements from this list, if you are holding it with the animal object, that's fine, because anyhow every time this list is going to consist an animal only, whether a dog or a cat or Indian cat or husky, whatever you have over here, they all are animals. So I can fetch them and can paste them as animals. So that's fine, right? So that's the most secure thing that I can do. So I can just write animal over here. So you cannot say, okay, I will be fetching them as cat, because it is very much possible that somebody will pass a list of dog in the runtime, right? So consider that scenario. So we'll be coming into that. But right now I'm going to say the bound here is animal. So I will be fetching them as animals. So I'm going to say, let's just sys out animal. I can safely do it. So I can just say here that this is a animal producer. This list will be an animal producer. This list will consist of animal. So we'll be safely able to retrieve them as animal only. So these are the various type I can pass to this method parameter. Okay, let me give you a quick example. I'll be type that by myself. Okay, fast forward to whatever I have written. I'm going to be explaining you in a bit. So these are all are going to be question for you. So this is the method that we have. Okay, so I'm going to be copy out the method signature just to make sure that you are going to see this method signature all the time. Okay, I'm going to be pasting my method signature over here. So now you see the method signature. This is what that we have. Now you see I have a cat list over here. I've created an array list of cat. Now you tell me whether I'll be able to pass this cat list into this display animal method. That's correct or not? Anything that extends animal or the subtype of it. Now cat, a list of cat, I'll be able to pass into this method. So if I'm going to pass into this method, it will not bug me about it, right? So this is possible. Now the dog list, can I pass the dog list to this animal list? Absolutely, because the dog extends animal. Okay, now you have a Indian cats. Okay, well, the Indian cat is basically extending to animal. So I will be safely able to pass the Indian cat over here. Okay, so what about the husky list? So I have a husky list over here. So husky is a animal. So I will safely able to pass the husky list to here. That's also fine. Now, can you just tell the animal list. Now animal means I can put any type of animal. Here I have added the dogs over here. So the animal is the animal itself. So I can instantiate the animal and also can pass it to this list. So if I'll come to the animal list, I can absolutely pass it to here. Now, can you just tell creature list? I have a creature right over here. So I have created a creature list, and the creature can hold anything, right? It can hold the creature object itself or any of the subtype, let's say animal or cat or dog or husky. And here I have posted the dog object over here. Now, can I pass this creature list over here to the display animal? Look at the signature. Okay, can I pass in the creature over here? No, right? We cannot pass the creature list to the display animal because the display animal is going to complain straight away because of the bound that we have specified, and this question mark extends animal. Okay, but the creature does not extend animal. It's the super type of animal. Okay, the creature does not extend animal. It doesn't come below the inheritance tree. It's come above the inheritance tree, and the upper bound that we have set here is animal. So this is not possible. There is a compilation error here. Okay, now you say I have an object list. Now here I'm passing in some dog object because the super type is object. It can obviously hold the dog object. So can I pass this object list over here? No, because of the bound that we have. Okay, so the display animal is going to complain again that this only can accept animal or the subtype of it. So this is also going to be fail. Now tell me if I can do this. Can I do Control C and put it over here? It's the array list of animal, but look at that. I have different mixed type of objects over here. I have cat, I have dog, I have Indian cat and husky, and all this can taken by the animal list. And obviously the animal can hold a cat, it can hold a dog, Indian cat or husky. So I have put different heterogeneous element to this list, and obviously the list can use to accept heterogeneous element. So first of all, tell me whether this is type safe. This particular list, whether this list is type safe, because we are able to put different kind of object to this. And obviously it is type safe because declaration that we have over here is an array list of animal. So it should be fine as long as we are putting an animal. It should be fine with that. But we cannot put anything, something like animal, this is the animal list 2. Okay, so we cannot put something like animal list 2 that add off, let's say new string. This is not possible because string does not extend animal. Okay, so do not get confused that here I'm breaking the type safety. No, I'm not breaking the type safety because the cat is an animal, right? The dog is an animal. The Indian cat is an animal. The husky is an animal, right? So I have a mixture of thing over here, but don't get confused. As long as I will be passing in the animal, a list of animal, or any subtype of that, this method will be fine. So I'm creating a list of animal and I can safely pass it in over here. That also work fine. Okay, I hope that you understand that, and my display animal method will be able to process any of these things that we have. All my method will work fine, I believe. Do I have any compilation error? For the object list, we have a compile time error. For the creature list, we have a compile time error because here is a bound. Okay, I hope you understand that. Let me run this. So do okay. All right, so I'm able to fetch all this objects that I'm putting in, and all this println statement is printing the different thing that I'm putting in. So my methods are working fine. Okay, now I have another question. Let's say Control Z, because all this question you will have, while practicing. So I will just make sure to cover this thing. Okay, so now let me remove the object list from here, creature list from here, and animal list from here, and the husky list from here, and Indian cats from here, and dog list over here, cat list over here. Okay, And what I'm going to do, I'll go to this display animal. I'm going to change this extends to, let's say, dog. Okay. Now look at the inheritance tree. I have the dog over here. Okay. So what this particular list will accept, it will only accept a dog or a husky, right? So it can only be able to accept a dog and a husky. It won't accept an Indian cat or a list of cat or any animal. It will only accept these two types, isn't it? So if you're going to practice, just try practicing in the same way. So if you're going to scroll down, here I have the cat list. If you're going to put it, so this is going to complain. The dog list, no, it is not going to complain. So Indian cat, this will complain. The husky, it will not complain because it's a dog. The animal list is above the dog. So upper bound is dog. So it will also complain. Creature list, this will also complain because this is above the dog. The object list, this will also complain. And the animal list, this is also going to complain, right? So this will not compile. Only this will work. This dog list will work, right? I hope you understand that. Now let me confuse you a bit. So I do understand that the rules that we have over here is producer extend. So anything that we are putting over here is just like a producer. So we'll only be able to fetch elements from here. We cannot stop things inside this particular list that we have. Let's say if I say animal, then it's very likely possible that somebody will send me any kind of animal. So I cannot just say animal list dot add, and I cannot just say new cat, because this is very much possible that somebody will send me a dog list and I'll be able to add a cat which is not actually a dog. So I'll have a type mismatch. So if somebody will send me a dog list, and if I'm going to add a cat and dog are two separate things. Cat is not a dog, so the cat type can be go inside the dog list and can cause problem and can break type safety. I do understand that. That's why it is not allowing me to add it. Okay, let me create a little bit of confusion over here. Okay, so your understanding is fine. I think till now you understand that what is the problem that we're going to be having. Now let's say if I'm going to have dog here, so I can safely fetch elements as dog. Okay, so it can also fetch elements as animal, but why should you fetch elements as animal? Because the super type, the bound that we have is dog. So we can just say dog because we can fetch elements as dog, or the subtype if it is coming like husky. If somebody passed the husky elements, then also we can fetch the husky as dog. So in the runtime, I know I'll be getting I'll be getting a dog list. I can just change this to dog list, or you can understand animal list, which will consist a list of dog. So I can safely able to fetch a list of dog. Now tell me if I'll get a dog list. So in this scenario, I know that husky, this list I can able to pass it over here, or the dog list. This is also going to work fine. You can see there is no red mark over here. So dog list also I can create and I can pass it over here. So these are the two valid use cases that we have. So my question is, imagine here I know the dog list is going to become in any given point of time dog or any subtype of that. Okay. So if I will do animal list, okay, this is a question for you, dot add of new husky. What should be the problem if the compiler would have allowed us? Now, we know that add we cannot do with the extends. That's the rule. That's the thumb rule. You are correct. We cannot add anything. That's what we have learned. But what the problem would have happened if it would have allowed us to add it, husky. See our use case. What we will get? We'll get a dog list, okay, or a husky list. We'll get a list of dog or a list of husky. Imagine we are getting a list of dog here. For an example, list of dog, where it is. Oh, there you go. Okay, we have a list of dogs over here. Imagine we are having a list of dog with 3 dog object. Somebody is passing this one. So we have 3 dog objects. So this list of dog, Control C, let's say I'm gonna write like this. So this will come, okay, containing all this element, and this list, dog list, will be assigned to here, okay. That list will come, and that dog list will be assigned to this animal list. Now, if that's the case, now I know that's a dog list, okay. So I would have able to add husky inside the dog, right? The dog husky super type is dog. Husky is a dog. I would have able to insert it, isn't it? That's the value scenario. This could have been done. Or imagine if you have a husky list. Where is the husky list? Okay, husky. Yeah, husky is also a dog, right? Now, if I have a husky list, imagine the husky list. This object will come, which contain all this husky, and I'm passing this husky list to here. Imagine this object will come in the runtime and will be assigned to this. Okay. Now this can safely take an husky object because it extends dog. That means husky can be assigned. Now, if husky object will come, I would have safely add a husky over here, right? So with dog or with husky, I would have safely assigned the husky object over here. But in this use case, why this is complaining? Yeah, this should complain because with extends we will not be able to add, that's fine. But in this example, why it is complaining? Any thoughts that you're having? And you're correct. So we're saying dog or any type of dog. So in this use case, it's a very simple use case. We have only one type called husky. So we are saying, okay, we'll be getting dog or husky. But in future, imagine somebody will have one more dog breed. Okay, let's say somebody will have one more dog breed. Let's say German Shepherd. Okay, German Shepherd. So is German Shepherd is extending husky? No, right? So German Shepherd is a separate type, which is a dog, right? Now imagine if somebody will send a list of German Shepherd. Let's say list of German Shepherd, okay? If somebody will send a list of German Shepherd, the dog is well able to hold it because the German Shepherd is a subtype of dog. So in that case, if I'm going to get a list of German Shepherd, and if I'm adding husky to this, then there's a type mismatch. With a list of German Shepherd, I won't be able to do this because husky is not a German Shepherd, right? So, if I'm going to get a list of this, then this will be going into that German Shepherd list, the husky, and there will be a problem, right? So if you have this kind of question, just try to avoid that particular question by writing use cases like this. And once you understand this is, sorry, I did some Control Z. Okay, not a problem. So if you understand, once you understand this is going to be very much easy to digest this concept. To spend some time initially, it will create some confusion, but once you try to solve it by spending some time, this will be very, very simple. And I think you understand that. You also understand the producer extends rule. It's always going to be a producer. We're going to be reading elements from the producer. We won't be able to add it. Extends means always get. We'll be always be getting elements from this. Okay, we won't be able to put element. We won't be able to stuff things inside this particular list. Understand that, right? So this is how we have achieved contravariance in generics, isn't it? Contravariance means to this list, I'll be able to add any substitute to a list of dog. Okay, Control C. To this, I'll be able to add a new array list of husky. Okay, so husky. Okay, so this is possible. So this is what we call covariance. Did I say covariance or contravariance last time? So this is what we call covariance. Okay, so covariance is possible by using the extends keyword. You can see the dog type was needed, but I'm able to pass the husky object over here. So this is what we call covariance. Okay, but by default the generics is not covariant. This is invariant. Okay, by default, if I'm gonna write, if I don't use the extends keyword, okay, if it is asking dog means you have to give dog, right? So this is basically invariant in nature. The Java is invariant in nature. It is asking dog means you have to give dog over here. It cannot be husky. If you want to write husky, it is going to be complaining. So it should be the exact match. And invariant means this thing cannot be changed. Invariant, variant means changing. Invariant, it cannot be changed, right? It cannot be substituted. Even it cannot be slightly substituted. It should be the exact match. So this is your invariant. Okay, this is your covariance. Okay, now in the covariance, we have seen a problem here. Though we are able to read things, we are not able to add things. Okay, now what if I want to add something? What if about I want to accept a list, animal list, and inside this animal list, I'll be able to add an object, let's say new dog or new cat or something I want to add to this. So if I want to add something, then I have to learn a concept of contravariance. And the contravariance means going in the opposite direction. I'll tell you why exactly you need contravariance, but this is covariance. Contravariance means, see, if you have list of dog, okay, so you will be able to add a more generalized version of dog. So who is the dog super type? Okay, dog super type is animal. So let's say if I'm gonna say list of dog, can I add it like new array list of, let's say, animal? Is it possible? It's not possible, right? Because it should be the exact match. The Java generic is invariant. Okay, so if you're gonna do some wildcard extends dog, that then also it is not possible because it needs dog object over here or any subtype of dog like husky. Okay, but what I want to assign a super type. I don't want to go down. I want to go in a opposite direction. I want to go contravariant. Okay, contra means opposite, against, I feel. So dog, I want to assign an animal. I want to assign a creature. I want to assign a object. Is it possible? Yes, it is possible. But to achieve contravariance, you can just use super. If you're going to use super here, you can see this is, let's say, list 2. This is not complaining. So dog is here. I'm going to go opposite. Okay, I'm going to go opposite right now. I can also add animal. I can also add creature. I can also add objects. So let's just see. Let's say dog. I can add animal. I can add creature. And I can also add object. Is that possible? Yes. And this is what we call contravariant. Okay, this is what we call contravariant. Okay, I hope you understand. So covariant means here we need dog type, but we are adding some more specific type. Let's say dog was expected, but I'm giving it a husky. I need a yellow fruit, so somebody is giving me banana because banana is yellow. Somebody is giving me mango because mango is yellow, right? I need a dog, but somebody is giving me husky. I need a dog, somebody can give me a German Shepherd. That's covariance, right? But here in the super, so let's say I need a dog trainer, but somebody is giving me an animal trainer, right? Let's say I need a cat trainer, but somebody is giving me an animal trainer. They're going up in the inheritance tree right now. So I need a dog. Okay, you can pass in a super type object or more generalized object over here. That's what we call contravariance. Again, variance means changing, contra means against or opposite. So if I want to say dog, I can assign animal to this, creature to this, object to this. What about if I'm going to say animal? Okay, can I assign object? Absolutely, because animal super type is object. Can I assign a array list of creature to this? Absolutely, that is also fine. I can happily able to assign the array list of creature. Can I able to assign the animal itself? That's also fine, because I can go animal or a verb animal. Okay, so the limit that I have set is, the bound that I have set is animal here. So I can go animal, that's the lowest I can go, or anything above that, right? So animal, so I can go animal or creature or object. So animal or anything above that I can go. Can I go below that? Can I go cat or dog or Indian cat or husky? No, I cannot go like husky here. So it's the opposite of extends. So see, husky is giving me problem. Can I go dog? No, this is also a problem. Can I go cat? That's also a problem. Can I go Indian cat? That's also a problem, right? So if I'm going to write animal, means it should animal or anything above that. So the lowest limit. So whenever you use super, so that's what we say is the lower bound. Just like we say is the upper bound. Upper bound means dog is the highest or anything below that. If I'm going to use extends, I can put dog here. I can put dog here or anything below that. I can put husky or German shepherd if that extends dog. But I cannot go anything above that. I cannot go animal or creature or object. Okay. But here, when I use super, that means animal is the lowest. This is the lower bound. So that's what we call a lower bound wildcard. Question mark is the wildcard. And here the bound is animal. But I have used super, that means it's a lower bound. So I can go at least animal or anything above that. Animal, that means whether it will be husky is not allowed. So whether it will be object or whether it will be creature or the animal itself, but not anything below that. Okay. So contravariant. So whatever you're going to be specifying over here, you can define a more generalized version of this. Generalized means going the super type. So animal super type is object. You can safely assign that. Creature is also animal super type. You can safely assign creature over here. So it's the opposite of covariance. Okay. So the practice this a little bit and familiarize yourself. And now we'll understand why do we need covariance. Why do we need contravariance? We understand covariance. Why do we need the contravariance? And we will look into some examples. And it's very simple again. Okay. All right. So coming back to the super part, I'll tell you right now exactly how you will be using it. Okay. So I'm gonna be creating a new method, by the way. I'm gonna say public static void add animal. Now with the name you can guess it, because actually I'll be able to add an animal right now. Okay. So right over here in this method, just have a look into this method only. Into the add animal method. Okay, so if I before I go to the super keyword, if I'm gonna accept list of animal, this means what? This means this method can accept a list of animal. Okay, but it should exactly match this type, list of animal only. Okay, so if I will call this method for a minute, this is another very important thing. Understand this. Add animal. Okay, so this is my animal list, let's say 3. And here I'm adding a bunch of animal. And now I can pass this animal list over here. Absolutely, that's fine. Okay, so the thing is, if I will pass a direct match over here, animal, this is what it is expecting. So that's fine. Now this particular code compiles right over here, no problem, because I'm passing a list of animal, and this method also asks for a list of animal. Now I want to have you look into this method only. Okay, so that's fine. So you need to remember one thing. If this is the case, you can actually read from this. Let's say animal, and let's say animal list. I'll change this variable name as animal list, so there is no problem, right? So I can just do, you'll be able to read from the list, and if you like to add something, let's say animal list dot add, you can add any animal. So if this is going to take an animal, you can also add a new dog. Okay, dog is an animal, or any of his like any of the animal or any of his subtype. Let's say new cat also you can add, or you can add anything. Let's say you can add a cat, you can add a dog. Okay, that's fine. So basically, whenever you have a list of animal as a parameter, then obviously whenever you'll be invoking this method, you have to pass a list of animal only. Okay, but inside the method, you can also retrieve the animal from the list, and also you'll be able to add something to the list. Okay, so let's say if I'm going to do this, and if I'll come all the way to down, and let me just comment all the other methods that we have. Okay, I'll just execute this lines of code right over here. I'm going to say animal list 3, animal list 3, sorry, animal list 3 and animal list 3. Okay, I'm going to pass in this animal list 3. That's fine. I'm passing in 3 dog object, and I'll be able to retrieve all the elements, and also I'll be able to add elements. Maybe the retrieve code I can write over here. Okay, that's fine. Now if I'm going to run this, okay, you can see I have 3 dog objects in the beginning. Then I have added a cat, and I have added a dog. That's fine. So if there is an exact match that you are sending, then you can add also, and you can retrieve also. That's fine. But let's say, as I have told you, if I will copy this, and if I'll make it a array list of dog, let's say, okay, and let's say dog list new, and I'm going to be changing this. Okay, and if I'm going to be passing this dog list new, sorry, right over here, if I'm going to be passing this over here, then there will be a problem. So now if you want to pass a subtype of animal, and if you want this method to accept it, then you have to go with extends. And when we say extends, that means here I'm ready to accept anything as long as it is an animal. Okay, and dog list I'm getting over here. So dog is an animal, so that's fine. So I'll be able to retrieve thing, but I will not be able to add things. So this add code will no longer work if you're using covariance or extend thing. So extend thing means you'll treat this as a producer, and you'll only be able to read things from this particular animal list. We have already discussed this. Now if you're going to see this code, this works fine, and also this works fine. So animal list also I can pass, dog list also I can pass. If I want to run this, you can see dog, 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 and here also I'm adding 3 dogs. Okay, so that's fine. But now the question is, let me remove this dog thing. Now the question is, if I want to pass a more general type over here, let's say animal I want to pass, otherwise I want to pass a creature or an object. Can I do that? Now, can I pass a creature list I want to create? And obviously I can add in the creature, I can add either animal or cat or dog or Indian cat or husky. Let me remove the German Shepherd. And let's say to the creature, it can hold any of this thing, right? So let's say I have a creature list and I want to pass this creature list over here. Now, if I do so, now there is a problem. Now, if I'm going to go to the add animal method, it is going to complain because right now it says it can pass only animal or anything below it. Now, I want to pass animal or anything above it right now. Okay. So in that case, here the extend thing will not work. I can also accept a more generalized version of animal. Like I can be more general, like object or creature, which are the super type of animal. Then here I can go for super and can set a lower bound. And as you can see, if I can do that, first of all, you can see this code compiles. Right now I'm able to pass a creature list. Let me just say creature list. I'm passing in a creature list. So I'm able to pass a creature list with an add animal method which accepts animal or anything super type of animal. And you can see that that is fine. But the reading thing right now giving me a problem. I won't be able to read the thing. I cannot able to read the things as animal. And obviously that's fair. How can I read the things as read this animal list as an animal? Because this animal list right now contain a creature list. And do you think I can get a creature object and can set it to animal? No, that's not possible. I cannot do this, right? Can I do this animal list dot get and let's say get of 0, and can I set it to animal here, going with our last example? Can I do this? Here the bound is animal. Can I put animal here? No, I cannot, because this animal list, as I'm using super, I can get animal, that's fine, but I can also get the super type of it. I can also get a list over here in the runtime, which is list of creature or maybe list of object. If I'm going to get a list of object here, or if I'm going to get an object back over here, how can I put the object inside the animal? Or if I'm going to get a creature over here, right now I'm sending a creature list. So now this is the creature list that I have. Let's say I'm going to take this and let's say imagine you have all these things right now fitted inside this particular list that we are creating. Now, if I'm going to be sending this list to the add animal, now that will be assigned to this guy. And now it is going to get me a creature. Maybe the creature object, then again holding the dog object, whatever it is. But I'm going to get a creature object. The creature cannot be set to animal. That's the wrong thing, right? So I will not be able to read the thing as animal. Rather, whenever you want to handle it, every time you'll be able to. So you can also you can say creature. Can I write creature over here? Well, this is also not possible. How can I write creature? Because right now, for this example, this works fine, right? You can think, okay, I'm sending a creature, so maybe whenever I'll be retrieving, I can get a creature, so maybe I can write creature over there. But think about this perspective. What about I can also send an object here. Let's say object list. I can add all these things to the object. You can add anything to the object, dog, cat, whatever, right? Now that object I'm sending over here. So in this case, let's say you will be getting an object list back assigned to this in the runtime. So whenever you do get 0, you won't be getting a creature back. You're going to be getting an object back. So to be in the safer side, whenever you will be retrieving the element, it is always going to give you back in form of object, right? So whenever you see something super is written, so the super means if you're going to do retrieve from the list, it's always going to give you back the elements in form of object only, because you don't know over here what kind of list you're going to be getting. Either you're going to be getting an animal list or you're going to be getting the creature list, or you're going to be getting an object list over here, right? So whatever you're going to be getting, the most safest thing you can do is you can retrieve those things as object. So you can retrieve, but you can retrieve things as an object, right? So you can put this animal list over here and you can retrieve things as an object and it will not give you any error, right? But in reality, we don't use the super thing for retrieving. As I said, the retrieve thing we can do for the extents. With extents, we can retrieve it as a specific type. But here we cannot retrieve with the super as a specific type over here. We cannot retrieve things as a dog or a cat or whatever, because we don't know what this guy will actually contain. Okay, so the safest thing we can do, we can just go with the super type. We can go with the object type. So every time whenever you're going to retrieve elements where the super is written, you're going to be getting things in object type only. Now, this is not why the super thing is used for. Now let me remove this. The super thing is used for adding elements, because that's the disadvantages we had over here whenever we had extents. Whenever we have extents, we won't be able to add something to this list. But whenever we have super, okay, some unknown type, which is the super type of animal, that time we'll be able to add elements. And see, this is not complaining. And now just understand why it is allowing you to add. Okay, first of all, just concentrate over here. We will see what we can pass and all that thing later. Now say you are writing this method, add animal. So what you are saying, this list will contain either list of animal or list of creature or list of object. That is the three possible probability of object we will be accepting in the runtime. Now over here, to think logically whether it is safe to add cat or safe to add a dog, because it is animal. We know whatever will be coming to this will be at least is going to able to hold this object. Let's say we're going to be getting a creature list. So whether I'll be able to fit in a cat inside a creature? Yes. Whether I'll be able to fit in a dog inside the creature? Yes. Because for the dog and the cat, if you're going to see the hierarchy, creature is the super type. Okay. Or I can add an animal itself. Animal list dot add, let's say new animal. This is also possible, right? Because let's say I'm going to be getting, if I'm going to get an animal list here, imagine over here, if I'm going to getting a new array list of animal, if a concrete list of this is going to be assigned to me, then obviously I'll be able to add an animal to this list. I'll be able to add a cat to this animal. I'll be able to add a dog to this animal list. That's fine. I'll be able to add, let's say, new husky to this animal list. That's fine. Okay, let's just talk about another probability. Let's say this one that we have over here will get a array list of creature in the runtime. Okay, if I'm going to have this, can we fit an animal inside the creature list? Yes. Can we fit a cat inside the creature list? Yes. Can we fit in a dog inside the creature list? Yes. Can you fit in a husky over here in the creature? Yes. So I can safely add all this thing to this animal list, because whatever will come in the runtime as a parameter, whatever list will come, that will be either list of animal or list of creature, or it will be list of object. And if I'm going to even say a list of object, if I'm going to get in the runtime, okay, over here if the list of object, I'll be assigning to this, and I can see that works fine. And even with the list of object also, I can put in an animal or a cat or a dog or a husky, because for every type that we have, the super type is object. So I can safely add elements if you're going to write super, because I know the lowest. So this is what I say, lower bound. Wildcard, super, animal. That means animal or anything above that. I cannot go below that. So the lowest I can go is animal, right? If the lowest I can go is animal, then I can feed in all the subtype of animal over here. Animal or any subtype of animal I can feed in over here to this list, because I know in the runtime I'll be getting objects which will be animal list or object list or a creature list. So with all that, I'll be able to fit in all these things, right? Because that's why I say this is the lower bound. The lowest I can go is animal over here whenever I'll be accepting the list, but I cannot go below that. I cannot pass a list of dog. Okay, I cannot pass over here. If you can come here, the object works fine, and you can see the creature works fine. Even the animal will be work fine. Let me test with the creature. Let's say I have a creature list and I'm adding the animal over here. Okay, and add animal method, I'm passing in this. So this add animal will take the creature list and will add all these things, right? Let's just go back. Okay, and then again I'm gonna print the creature list 3. Let's just see what is going to happen. Run this Java application and see, I'm gonna get dog, 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 and then I'm gonna get all the other stuff. Let's say animal, cat, dog, and husky, and all these things that I have added over here, and that has been safely added, right? Because this is a creature list and I can safely add all the subtype of it. Okay, and like that, if I will do one thing, if I will Control C this and put it over here, and I'll comment this thing. Okay, let's say I'll also comment this thing. I'll uncomment this. Okay, and I'll call the add animal method with the object type over here, right? Let's say I'm putting 3 dog object, and I'm gonna print this over here. That will also work fine. Okay, let's just see. I'm gonna get dog, 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 and then whatever I'm gonna be adding over here in this method. So let's just run this. Okay, this also worked fine. Let's say dog, 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 and then animal is being added over there, cat is being added, dog is being added, and husky is being added. Like that, I can also test this with animal. This will also work fine. And let's say here I'm gonna add something else, say cat, let's say husky, because I can put anything inside this animal as long as it is an animal. Okay, and these 3 things I'm putting over here with my list, and another 3 things that I'll be adding by calling the add animal method and passing in this animal list. Okay, let me comment this thing. Okay, let me print this as well. Control C, put it over here. Animal list, can I put it over here? And there you go. If I'm gonna run this, this will also work fine. Okay, cat, husky, cat, husky, and dog, and then another 3 things there, animal, cat, and dog, whatever that I have added over here, all those things is on my console. Okay, this is the only 3 types I can pass in over here into the add animal method, either an object, creature, or an animal, but I cannot put anything below animal. Okay, so for an example, Control C and put it over here. Let me just comment out everything. And let's say I have a list of cat. Then I can say add animal, and I can put cat list. Okay, and you will be able to see I'm getting a compile time error because the method signature is something super animal or the super type. I cannot go below that. I cannot assign a list of cat to the declaration that I have over here. Okay, to this that I have over here, I cannot assign a list of cat because cat is not the super type of animal. Okay, cat is below animal. Okay, the lower bound is animal, so I cannot go below that. I can only go above that, and then only that can be assigned to here. And here is the proof for that this is giving me a compile time error. So if I'm going to come down, this is not possible. This will not compile. So if you're going to see the add animal method, what do you understand while looking into this method? That the list you're going to be getting, like that will be this animal or the super type of animal. So I can easily feed in all these things to the animal list. Okay. So here I can absolutely able to add things. I can absolutely able to add animal object or any subtype of animal object. That's fine. Okay. So whenever you see super, that basically used for adding elements to the list. If your need is only to add elements to the list, then you can use super thing. Okay. And that's why we say, consume super. I have told you the rule, right? Producer extends, consumer super. This is the rule. Okay. Producer extends means, extend keyword means, as I said, it is going to be treated as a producer. It will produce the value and will be able to read things from the producer. Will be able to get things. We can able to read things. Okay, we cannot able to put things. We can only be able to get things. So this is only used for get method. Okay, but here we said consumer super. So for the super, we can treat this animal list as a consumer. Whenever we're going to be getting a list over here, this will be used as a consumer. It can consume value. Like this, see, animal list is consuming animal. Animal list is consuming cat or consuming dog or a husky. So if you're going to use super, we'll be able to add stuff in. We can put stuff in, or this list can consume things. That's why we say consumer super. So that's the rule. And some people also call this, I think, get put or put get method. If you hear something like this, get put method, get means it's only extend. Put means we can put things in. It will be super. It will be for super. Okay. So what do you understand over here? If your need is to add elements, okay, then you go for super, because here you know that at least an animal you're going to be getting. The mystery box example that I've given you, think like that. Here you have a mystery box. Okay. Imagine you have a box. For the compiler, you have given the compiler, hey, this is my this is the box that I'm getting. And compiler say, okay, you are using super means I'm sure you'll be using this box so that you can add element to this box. And compiler said, okay, I'll allow you to add elements inside this box called animal list as long as it is an animal. I don't care what are the types you are putting, but it should be animal. It should extend animal. So you can put animal, cat, dog, husky, whatever. But now the compiler says, if you're going to read it, by the way, I cannot give you the specific type because I do not know what things you have put it inside this. Okay. So whenever you'll be reading, let's say animal list dot get, I will only be able to give you in form of object only. Okay. So if you're going to write a for loop, I will not allow you to extract it as a specific type. Okay, that's the super thing. And here, whenever you write extends, the first thing, the compiler will not help you to add anything to this particular list in the first place. And the compiler will say, okay, I have a box. In this box, I have a group of dogs. Okay, because here I have written extends dog. I can go at least, the highest I can go is dog, or anything below that I can go. I cannot go above dog. So I have a box and it extends means I already have contents inside this box. You'll be able to read from this content. And whenever you're going to keep on reading elements, you can retrieve as a dog, because I can safely say whatever the elements that I do hold here, is dog or any subtype of dog. So I can safely retrieve as dog. So not a problem. But here the retrieval guarantee, the compiler is not giving whenever you are using super, and it will only allow you to read it as a object. So it is of no use. But the good thing is we are able to add animal or add any kind of animal as long as it is an animal. Okay. Now I have a question for you. If I write here super, let's say cat. Okay. Then what do you mean by that? If I'll write super cat means, see, now I'm having problem, because as I said, once you write cat over here, you'll be able to add elements because I'm using super. But can I add animal? No, I can only be add elements which is cat or the subtype of cat, right? The animal cannot be added over here because it's not a subtype of cat. The cat can be added, yes, the cat or any subtype we can add. Yeah, we can add cat. Can we add dog here? No. Can we add husky here? No. But can we add a Indian cat here? This basically extends cat. Sorry, my microphone is here. Can I write Indian cat? Yes. We'll be able to write Indian cat right over here. That's fine. Okay. So this is good. And what kind of thing that this can allow right now? It can allow right now a list of animal, list of creature, list of object, and also I think it can allow a list of cat as well. Okay. But I cannot pass a list of Indian cat to this particular method, or I cannot pass a list of dog to this particular method because the cat does not extend dog. Okay, I think this makes sense. So now we can think of that if I'm going to get a list of animal that can hold a cat or Indian cat. If I can have a list of creature that can hold a cat or Indian cat. If I'm going to hold a list of object that can also hold a cat or an Indian cat, right? So that's how the super thing can be used. It can be used to put things in over here. If your requirement is a consumer, you want to consume something, your list want to consume, your list, you want to put something inside the list, you want to put some stuff inside your list, then you can use the super. Okay, so super means is contravariance. You can pass in a super type like cat super type over here to this method parameter. Okay, and then covariance means here you can pass in a more specific type. Let's say you can pass in dog or a specific type of dog. Let's say husky, a list of husky you can pass over here. So that is what we call covariance. But normally Java is invariant. In Java generic is invariant. So invariant in the sense, if you're going to write something like this, let's say if you're going to be very specific, like I want to do the, let's say I'm going to have display animal new method, and let's say here I'm going to be accepting a dog list. So here the benefit is you need to pass in a specific type because Java generic is invariant if you're not using super or extend. But here you can able to read, or you can also able to write. If you are using the normal invariant case, you can do read, or you can actually write like this. Okay, so invariant, invariant both read and write, covariant only read, then contravariant you can do only write but not read. Okay, I hope these things are making sense. And one type of question you might have, I will also give you the answer for that. Okay, for an example, you can see, okay, I have a cat list over here and I'm going to be passing in a cat list over here. Okay, so that's fine. It will be able to allow this because the super is cat, and I'll be able to add a cat or Indian cat. So never have question like, okay, why it is allowing me to add two different types. Yes, it is two different types, but Indian cat extends cat. So here with the cat, you can either put cat or Indian cat. So that's fine. You cannot put a string though. You cannot put an integer though, because they does not extend the cat. So this is straight away going to give you the error. Or you should not have this type of question as well. Like, okay, what about I'm going to put an object. Let's say I'm going to take an object type. Let's say I have 3 cat over here. Okay. But here also, I'm going to do this. Let's say new integer. Can I do this? Absolutely. Because this is object type. Let's say I'm going to say it's object list. I can put any type of things in the world over here inside the object because it's the super type for anything. Okay. Then can I put this object list over here? Absolutely. Right? Because a list of object, as per the rule, the cat super type is animal, creature, and object. So object can be safely passed over here. Now if we're gonna run this, okay, let me print this. Okay, if I'm gonna print this, run this. Okay, I'm gonna get a cat, and then cat, and see 10. I'm able to put an integer over here, right? And then I have cat, and then I have cat. Now some people will question like, okay, in the add animal right now, the object list that you have all these things. Now over here you have added these 2 things. Now how you are able to push 10 over here? Okay, this is breaking the type safety. You are correct. But the type safety things, whenever I'm saying, just see in the individual context point of view. Here in the add animal method, here, this is what the type safety guarantee that you'll be only be able to add cat or Indian cat. Can you put integer here inside the method? Can I do new integer of 10 here? No, you cannot do that. It is straight away gonna tell you that, okay, you cannot be able to put this because it should be super of cat. Integer is not the super class of cat, right? It is not going to allow you. So this is the type safety. The type safety is inside the method. And over here, this is a design smell. Why did you, first of all, you have inserted integer over here, right? Why you are trying to mix up integer with cat? Okay. But you have taken this as an object type. You're telling that, okay, Java, I will take array list of object. That means you can put anything over here, right? Java is allowing you to put a cat or an integer or a dog or foo or watermelon, anything it will accept. Okay. But you should not do that in the first place. Okay. You should go for more specific type over here as cat. But this is allowed. This is allowed to take this, but still it is type safe because even though you're doing it, let's say inside the add animal method, let's say in case you are trying to retrieve, right? As I've said, still you will not have any class cast exception. Why? Because the animal list over here, it is going to give you object back in any given point of time because that's how it is making it type safe, right? If it is object, then if you're going to retrieve all the elements, you don't have to cast it by your own and you will not run into any class cast exception. You won't be trying to cast an integer 10 to a cat and you will not be running into that class cast exception thing. See, I'll be safely able to retrieve all these elements including 10 as well because I'll be only be able to extract things as an object. So type safety is not just only putting the element inside this list. That at that time also Java is doing the type check that, okay, whenever I'm adding cat, Indian cat, only the cat things I can add to this animal list. And while fetching the elements, if somebody will assign an object type list over here, then that thing also it is taken care of by while extracting, it is only allowing us to extract as an object. Okay. So the type-safety is guaranteed here. You won't run into the class cast exception. So if you have some weird questions like this, I think this is covered. So generally, make sure that the type things you are taking care of while passing in the things. So mostly for adding, you have an empty list like this, and you'll be passing that. And end of the day, you are adding things inside the list only, and whatever things like cat and Indian cat you're adding inside that particular method, that should be done over here inside the method, because super means I'll be adding elements over here only. Okay, so that is PECS rule, producer extend super consume or get put method. I think you have a kind of clarity that what is what right now, and you can do more hands-on on this, but I'll try to go with some of the real-time examples. I'll look into the collection API methods, and we'll try to find use cases for these scenarios. And that's what will come up in the next video. I think I've spent quite a bit of time over here. It's a topic for 10 to 20 minutes, but we have taken around 2.5 hours over here, or 3 hours, I don't know. But I think at least while practicing, you will get idea with a lot of examples given over here. At least you understand what is what. Okay, and what is contravariance, what is covariance, and what is invariance. Okay, that's it. I'll see you guys in the next video. Till then, bye bye, take care, and happy coding. Make sure you subscribe.